Yes, thank you. Hello, everyone. So my name is Michael Garcia. I'm working at Amazon Web Services in EMEA as a solutions architect, and I have a specialty on IoT and mobile. So thank you for joining this 1 hour webinar. Today we'll talk about IoT. What to expect from this hour is a little bit of context to start and to introduce IoT. Then we'll go on into deep details about AWS IoT, which is our managed service to connect your objects securely to the cloud. Then we'll go on with some customer reference. The idea here is to give you some use cases and to explain to you what customers have been doing with IoT. So hopefully this will give you a lot of ideas to implement. And then we'll go on to the IoT ecosystem. This is an important part because we have partners that can help you achieve your projects, and also there will be information on how to get you started with IoT if you want to start today. And then at the end, we'll have some time, probably 5 to 10 minutes for some Q&A. So again, in the tool that you have, which you are using to connect to this webinar, you have a section to ask questions. So don't hesitate, as soon as you have one question you want to ask, just post it into this tool. And then at the end of the session, I can answer them. Also, we'll have a live demonstration at the end of the webinar. So I'll switch back to a web browser to do that and to show you. Right, so you probably have heard of IoT, and maybe you have seen this slide already. Analysts are predicting that by 2020, we'll have more than 50 billion devices. That is the pessimistic prediction. The most optimistic one are analysts saying that we'll probably have more than 300 billion devices connected. So you can see that everything will be connected in the future. And to give you a few examples, we can play a little game together. So the good question that you can ask is, where are we on the curve? So here we have objects. You can use the chat window in the tool to answer this question. How many objects do you think are connected today, and how many already exist? So while you are giving your results, we go through the objects. So we have just a tennis racket, a dispensary for medication. We have a lock that can be a connected lock, also a plate, a teddy bear, and just some equipment to put water into your garden. In reality, all those objects are connected today. They are all being produced by either a big company or a startup, but you can buy those objects in the field. So that gives you an idea and puts in perspective where we are today. And each day, there are more and more connected objects. The important thing is that this is the fun part, the object that we can see like this, that are more targeted towards B2C, toward end customers. So, for example, some of you have heard of the CES events in Las Vegas end of last year, and it's showing a lot of different kinds of objects. For example, drones that are connected, and that would be the camera of the future. But it's the visible part of the iceberg and of IoT today. The real value is into the part that is not visible directly, but that comes from the industry. So again, we'll talk about that more when we talk about customer references. But for example, if you take a utility company that can do smart metering for gas, for electricity, for water, this is when IoT is useful. It will enable you to create more value for your business, hopefully to connect more with your end users as well, and provide services that you couldn't before. So this is where your customer will be very happy, and this is where your business can really grow up. So IoT, think of it as bringing more value than ever before, thanks to the data that you will collect and the action that you can have with your sensor and actuators. So the value comes from different places. One places it can come from that is automatic is from the data, and there is three ways to analyze the data. There is the kind of analysis that is retrospective, meaning that you will analyze what's happened in the past. So for example, in your company, this can be the role of a data scientist that will look at trends of the past. For example, what happened the last year, the last 5 years, or the last 10 years. And you can see pattern that will emerge from this analysis and hopefully, improve the business from that. So we have a dedicated tool for that. Then there is more the present data, the here and the now. So for example, if you have a facility, you have trucks coming in with the orders and new packages each minute, the people that are managing the facility will want to have a live dashboard with the live data. So here what's matter is probably the last 5 minutes, the last hour, the last 6 hours, for example. But it's not going, way into the past like with the retrospective approach. And then you have also predictions. It's a way to foresee the future, to predict the future with machine learning, for example. So here you, thanks to all the data you collected, you can feed that into your machine learning engine. So the model can be built. It's built from past data, things that already happened. And then you can ask him a question when the model is built, saying, okay, what do you think? Is this will happen in the future? Is that a probable outcome? And then the machine learning engine will reply back to you in real time and say, yes, you have 83% of that happening, for example. So again, you can create value with a lot of analysis from your data. And we have tools for each and every one of them. So in the retrospective tools like Amazon Redshift, when you have more data warehouse in the here and the now, Amazon Elasticsearch to build a real-time dashboard, and for prediction we have Amazon Machine Learning. The idea here, you can see a lot of different services. The goal is for you just to know that for each and every one of those tasks, the services that you will use will be different because you will not be doing the same thing. So that's why we have also different services on the AWS platform that can help you. Here are other services. Again, no need to remember them, but just to say that those are the ones that you will probably encounter when you are doing IoT. Why? Because again, you are trying to create value. So for example, the data you collected, you might want to share some of the data with your customers or with partners. And to do that, you will need API. So we have a service, as you can see on the right, called the Amazon API Gateway, when you can create APIs in 30 seconds. You will probably want to warn your users. For example, if a certain metric that is coming from an object needs to alert someone, send an email, send a text message, you can use Amazon SNS that you can see on the bottom. It's a notification service. And where is AWS IoT in all that? Where it's at the beginning. So you can see AWS IoT on the left. All your connected objects will access AWS IoT, and then AWS IoT will push the data to other AWS services that you need on the platform. So the IoT service is really a gateway, a way for you to connect your sensors and your objects to the cloud, and then be able to benefit from all the other services that the cloud has to offer in a very seamless way. And that's what we are trying to propose with AWS IoT. It's to securely connect 1 billion devices to AWS, so you can interact with them, and applications, mobile or web applications, can interact with them, and also devices can interact with them without the need of having an application to do that. The goal also, while trying to create AWS IoT, was to solve the different challenges that you will have as a developer. So, for example, all the components that you see on the left, they are part of AWS IoT. So you will get a message broker, so you can communicate with your devices. You will get security natively, and we'll go into more details later. You will get a rule engine, device shadows, and device registry. So now, in this section dedicated to AWS IoT, we'll go deeper into each and every one of those components, but think of them as solving a challenge that you would have as a developer. So for those who are already using the AWS platform, you know that one of aspects of our services is that they are scalable. This is one of the challenges you will have as a developer. So if you do that on your own without a managed service, let's say you take a server, you connect one object to the server, then you have the day after 1 million objects. What happens? Will your server handle the load? This is what we are proposing to solve with our managed service. So, for example, the scalability, it's completely transparent. You don't have to worry about it. So if you put it in a more architectural diagram, this is what you get, and we'll talk again of those parts in more detail. Let's start with the device gateway. That has two types of interfaces. One is the MQTT interface, the other one is HTTP. So many of you are already familiar with the HTTP interface, but maybe less with MQTT. So I'll give you a little bit of context around that. So MQTT is used for connecting objects to the cloud. It's a protocol that is dedicated to the IoT, and it will enable you to connect anything. So you can see on the picture a car, a temperature sensor, a fan, a robot arm, to the cloud and to exchange information. So what is MQTT? It's not a standard that is owned by Amazon. It's an open standard. It's actually a standard protocol from the Oasis Foundation. And we implement the version 3.1. And why are we using MQTT instead of using HTTP to communicate with objects? Well, it's because it's tailored to that space and to the IoT space. So this protocol has been there for more than 10 years now, I believe even more than 15 years. And it's very efficient. When you have connected objects, most of them, they don't have unlimited power. They run on battery. They don't have a lot of CPU. It's not like your laptop when you have an 8-core CPU, you are really constrained. So if you're using HTTPS, it's very consuming in terms of resources, and MQTT is way better in that regard. So you can observe a factor from a 10x to 170x, depending on what you are talking about, battery, CPU, or bandwidth, but it's really more efficient than HTTP. The other thing is that we said that the communication is bidirectional, meaning that you can receive data from your object, but you can also push data to your object. And with HTTP, that would be a lot more complicated. As you know, it's a client-server schema, so you can do a request, but then you would have to host a web server on your connected object to receive anything. So here it's really simplifying the communication with your objects. So how does that work? You have an object that will publish something, and it will publish it to what we call a topic. Here it's called my topic, and then you have someone that can listen to that. So if you are on the connected object that is the subscriber, in the SDK, you will do a subscribe on the topic, meaning that you are listening to any data that come onto the MQTT topic. And on the other side, you do a publish, meaning you send information. So that can be, for example, the temperature to the topic. As soon as you do that, if you subscribe to the topic, you will receive the notification. So MQTT really works like, publishing, subscribing protocol. And then you can do a lot of other things. For example, you can have multiple device publishing to the same topic, multiple device listening to the same one that will get the same information. But you can really do what you want, meaning having one device publishing to one topic, other device to other topic, and then subscribers that will listen only to the topic they want. Or they could even listen to multiple topics if they wanted to. So really here you have a lot of flexibility, and you choose the name of the topic. It's completely arbitrary. Well, so how does it work with AWS IoT? So you have the message broker. We are hosting that which is really, really important in IoT. Why? Because you must make sure that the data that you will send from your objects, that nobody can tamper with it, nobody can modify it. So this is where security is important, and will value security. Certificate before. For example, if you connect to a website, let's say it's the Amazon.com website, an e-commerce website, you have a certificate that will be presented to you when you're trying to establish an HTTPS connection. So when you try to connect, the server will present you the certificate, and you know that you are really connecting to www.mywebsite.com, and that communication are encrypted. So no one can intercept that, listen to it. But from the server, you are anonymous. The server doesn't know who you are. You are just someone connecting to the websites. We wanted to have a better security system for IoT. And what we are proposing is still the same thing. So on the left, you have the connected object. On the right, you have the AWS IoT service. When you're trying to establish a communication, so using MQTT over TLS 1.2, the AWS IoT service will present the certificates, and you will know, the device will know that it's trying to connect to AWS IoT and no one else. But so that part is okay. But you also have the other part. So you will have a certificate on the device, and the certificate will present the device to the AWS IoT service. That way, the communication is encrypted like before, but you have mutual proof of identity. That means that AWS IoT knows also who is connecting and who are the devices. So let me give you a simple example of what that can enable for you. If your customer is calling you saying, I bought your device, but no, now I've lost it, or it was stolen. I don't want anyone else to see my data. You can revoke the certificate that has been placed onto the object. You know that this object was bought by this customer, and then the object will not be able to reconnect again to the AWS IoT service, nor to send data, nor to receive any data. So you have protected the object in case of a loss or in case of a theft. So this is where mutual proof of identity is very useful. So this is for the MQTT interface, but we also talk about an HTTP interface that is available on AWS IoT. For all of you who have already used our AWS services, it's the same kind of security we always have. Our endpoints are protected with HTTPS. So you can make an HTTPS connection, and then you will have a set of access key and private key to be able to call the API and the authorization that comes with your keys. For those who don't know how to connect to one of the API of AWS, you can go on the website to know more and look for a service that is called IAM, for Identity and Access Management. Right, so now you are able to connect to the cloud. This is what we call the authentication, meaning that you authenticated yourself to the AWS IoT service. Then comes the authorization. Authorization is the right to perform an action, meaning in that case, even if you see, in red, the temperature sensors being able to authenticate and to connect to AWS IoT, they will have to publish data. You are the one controlling if they can do that or not. So you can give them the right to publish data. And then, for example, you could also act on the blue part, so the mobile application, or the green part, the fan that is somewhere else inside the same facility or in another country, and say, okay, I want the data that is being pushed, on this MQTT topic by the red sensors to be able to reach out to the mobile. So you would have to authorize the mobile to subscribe to this MQTT topic and to listen to that data. So here you have complete flexibility. You can say, for example, yes, I will authorize the mobile application and the fan to receive the data, or just the fan. And this part is very granular. So another example in real life would be a user that is buying one of your device. You want to give and only him access to the data coming from this device. So you can do that by only authorizing him being able to listen to that data on the mobile app and not someone else. So this part again is about authorization, and more details again are managed by the service called IAM, for Identity and Access Management, and this service will enable you to create those kind of policy authorizing people or objects to perform action, to publish or receive messages. Then comes the rule engine. Why? Because you are receiving data, but for now you're not doing anything with it, and you will need to do something with it. It can be storing the data, archiving it of one of our services, send an alert, send it to a NoSQL database, or whatever you want to achieve on the platform. So the rule engine is here to facilitate that for you. Again, as a developer, if it was not there, you would have to create your own rule system, saying, okay, when I receive this kind of data, I have to perform this action. Here you have a rule engine that has been built and that is ready for you. You just need to configure it. So in this example, if cars were to send data to the service, this data can be sent to Amazon S3 and analytic purposes, or by Amazon machine learning if you want to learn from the data and be able to predict things in the future. So how is it working? Well, there are a few steps. So you can see here all of the steps. You must select parts or all the data that the device is sending. So the data here is the payload that the device is sending from an MQTT topic, because you are listening, a rule is listening on an MQTT topic. And then you can add conditions. You want the rule to be triggered, you want the rule to be fired only when a certain criteria are met. And then if that's true, you can perform an action. So let's see this into more detail. So the first step is to choose what a topic MQTT you will be listening, what the rule will be triggered on. So again, you can choose whatever name you want for your topics. It's arbitrary. So in this case, you want to choose, for example, as you see on the bottom, I want to listen from the MQTT topic that is called my/topic. Okay, but again, you can put whatever you want here. Then whenever a message will arrive onto the topic, the rule will be evaluated, and you can select the data to then push somewhere else. So here again, it's the JSON object payload that is coming from the connected object. You can select everything, or you could select, just parts of the JSON. So here is the sample payload with the device ID, temperature, humidity. You can just select star to select everything, or again, you can go deep into the JSON payload to retrieve only what you need for this rule. And as you can see, there is an advanced support for JSON, and also you can have expression. So you can use calculus. For example, here, if you want to do an MD5 function on the device ID, you can. And you can do that directly from the rule engine. All of those expressions are in the documentation. But you have a wide variety of supports, and that is like with the where clause. When you want to filter, you have a whole set of clauses, and or plus and minus. Some of them may be recognized the SQL syntax. It's what we are using. Behind the scenes on the service, SQL is not used. It's just a way for you as developers to write a rule easily. We wondered, what would be the preferred language to manipulate data, and almost all developers knows already SQL. So that was a good fit. And we'd rather doing that than having something else, another language that you would have to learn. So here you can really easily write your rules for the rule engine. We even have a web interface, so you can do all with configuring the rule engine with the web interface. So here again you can filter on a lot of criteria. And you can build very complicated rules. This one is complex on purpose, but basically it will enable a device to react to what another device has been publishing. So you can see in the select, we select multiple things, the whole payload, the client ID, from the topic 1/rule clause, where we can filter on some data. For example, the hydro temperature must be temperature, and then the action that we perform is to republish an MQTT message to the other object. Well, we just talked about the rule engine, but not so much about the action that you could perform. So you just saw on the slide before that you can republish an MQTT message, but you can do a lot more as well. You can call other AWS services. There is a direct integration with the S3 SNS, Lambda, DynamoDB, Kinesis, SQS. We even have now Firehose integration, Amazon Elasticsearch integration, and more are coming depending on the feedback from our customers. And from the service, then you can target, the rest of the AWS platform. So other services like Redshift, RDS, Glacier, and you can also reach out to external endpoints. So if you need to reach out to third-party API, or maybe to an API that you are already hosting today, you can do that with much ease. So as an example, here is just one rule you could create. If there's something going on from the device, for example, the temperature is too high, or here the blue device sends information, then I want to send a mobile notification to my users. Or you could send an email or a SMS or a HTTP post, for example. And that is just using the SNS integration. The added value here is that you just have to do configuration with the rule engine. You just have to log on to the web console and then you declare your rule and they are in action. So you didn't need to, develop a lot of things. You didn't need to host your own servers. So really, it will enable you to go to market much faster than without using AWS IoT. Then comes the shadow part. It's an important part, and again, it's here to help you solve a challenge. The challenge this time is about the connectivity of your devices that you can see on the left, and about building secure web and mobile application fast and very quickly. So in the world of IoT, the devices sometimes are very constrained. They don't have good support, good bandwidth, or good connectivity. Sometimes you will just, implement in the programming that they should sleep and not send data for long periods of time because you want to be able to save battery and your devices must, be in the field for multiple years. So it's completely understandable and very much expected in the IoT world. So here, for example, you have a spectrometer doing analysis, and it will connect only when you want to send the results of this analysis. When it does that and send the message to AWS IoT, you can use Shadow to persist the state of the device. Okay, and then you can access this state, so the device shadow, with REST APIs. So from mobile or from web, you can access that very easily. Let's imagine you don't have that, and from your mobile application, you want to access the device directly. If the device is connected, then you can get your information. If it's not, then you will get an error. And you would have to handle that. Here, it's very easy. The state will be persistent in device shadow, so you don't have to retain it, and we'll retain that for you. So you can really code your mobile and web application fast and quick because you need to use those REST API, web services, and most of the developers already are used to that today. So here again, if you want to be able to display on your screen of your mobile application the state of your connected object, you can just ask that to the Shadow API and not directly to the connected object. If it goes offline, the code stays absolutely the same, and you will get the same information. So it's a way to decouple the connected object from the IoT application, either if it's a web or mobile IoT application. Here is the flow of Shadow, just to make sure that everyone can understand well. You will publish the current state, so the state of the device. Then this will be persisted by us. You don't need to worry about that. Then the app can ask the states. It can also order the state to change, so give you an order to the device to do something. And then this will be repercuted. The device will be notified automatically by AWS IoT. And then if he applies the state change, it will report back the state. So Shadow is a way for you to get data from the device, but it's also a way for you to give new orders to your device and to pilot them. And then you have the final confirmation that everything went well, your device listened to what you said, and it executed the order that you gave. So here is what Shadow looks like. It's just a JSON document. You can see there are three parts. The desired part in green is what you want to, what are your orders for the devices. So it can come from a web or a mobile application, but this part is only updated by the people or the system controlling the connected object. The reported part in red is what the device will send. It's the state of the device. You will say, okay, I'm in this state, in this position. And the delta is the difference between the two. So you will have automatic notification from the delta. So if you give an order, then and it's changing from what the current state of the device is, there will be a delta. Here it's that the connected object needs now to turn the color to red, and then it will get this notification and perform the action. So you can use IoT device SDK on your connected objects. When you do, you can get those notifications really easily, and you can see on the bottom that they are reserved MQTT topic for Shadow. They are beginning with $AWS/, and those are reserved topics, so you cannot take them. Right, one of the last part is the registry. The registry is a directory of all your things. You will have many connected objects to AWS IoT. You need a way to list them and to be able to put more attributes on them. So again, you will get that as part from the AWS IoT service. You don't need yourself to maintain this kind of directory. The use case that you can encounter are, for example, device management. So here, with everything that you just see, it's really easy to build a device management system leveraging AWS IoT and other services like S3, for example, and Lambda functions. Right, so now you have everything that you need to connect your objects, do it securely, be able to act on the data and pass it on to other AWS service to create your IoT and mobile application very easily. The pricing is pay as you go, so there is no minimum fees. You have a free tier of 250,000 messages per month, so it's really more than enough to begin testing. And then it will be $5 per million messages that are published to or delivered by AWS IoT. All the rule engine is free, the device registry is free, Shadow is free, and if you push data to one of the other AWS services like S3, DynamoDB, Lambda, any of those, they are free of charge as well. So the only thing that you need to take into account are the number of messages published by your objects and the number of messages delivered by the AWS IoT broker that are not sending data again to the AWS services. Right now, so let's take a little bit about what people are doing in the IoT space. You can see many references here. Most of them gave testimony at our last reInvent. So reInvent is our annual conference in Vegas. It was in last October, so October 2015. You can find with this link our YouTube channel, and we have a playlist of all the mobile and IoT sessions that were there. You have 18 videos there, so some of them have those customer testimony. If you want to learn more, please go and see those videos. Those are giving you great content. Right, so the first customer reference is John Deere. It's a company that builds big machines for the for agriculture. So it's in the agricultural industry vertical, and those machines are really big. You know, they have engines, they have hundreds of devices. So you would need them, to be connected to gather data on your machine, see how well they are performing, but also how you could, react in time to what's happening in the field. They are coupling that with also analytics and other data coming from other places. But bottom line, they enable their farmer who are using their solution to really be more productive and to do more with less on the field. So there is the video case study. You have the link, so go ahead if you want to learn more about John Deere. Then we have Philips, that is also one, sorry, just missed this one. Philips, that is in the healthcare industry. So again, IoT is big in the healthcare industry. You have a lot of connected objects, like for example, if you want to do blood analysis, or you want to control, monitor the level of sugar that you have in the blood, or your cardiac rhythm, things like that. And Philips really want to engage more with its end customer and be able to provide a better healthcare system. So with those connected objects, they can collect data from the patients. This data will be forwarded to the doctors, and then they can make better informed decision, because they will have more data for the diagnostic, and also they will be able to make them a lot faster. And you can even have, with machine learning, for example, you can imagine to have some of the monitoring handled by machine learning, and be able to detect some patterns and some alerts for the doctor to say, oh, for example, this data doesn't look right, maybe something is going on with the patient, you should check it. So those are the kind of use case that kind of in this space. And then we have Sonos as well. So for those who don't know Sonos, they are a company creating a sound system, and those are smart sound systems. So you can have, for example, one speaker into your living room, one speaker into your kitchen, one in your bathroom, and you can control, for example, independently which music is playing where. And what they did is that they connected that to the cloud to first, collect data, but they've been able to improve the experience on devices that they sold a long time ago. Because all the devices in IoT, it's really important that they are able to receive updates, because probably you will want to update them so they can do new things. And they, in their own word, a 10-year-old product can do things that are possible now, but that wasn't been invented 10 years ago. So by pushing updates to those products, they're able to, really enhance the customer experience and have a better lifetime also for the products. BMW also, it's in one of the keynote, reInvent keynote as well. What they are doing is that they want to connect cars. And with that, the car will be able to detect, for example, if there is ice on the road in the morning because it's very cold. So then it could alert, all other cars around, so drivers would pay more attention to the road, and also enable the map in real time. So all those customer references, you can group them, and whatever the industry, because IoT is in all industry today, and the thing they do is either they can optimize an existing system to provide more value to save costs, or they are creating completely new line of businesses thanks to what they can do now with connected objects. So those are the trends that we see. Well, the ecosystem now, you have a lot of SDK that are available for mobile, for web, for your connected object as well. You can get started with one of the IoT starter kits. So if you go on the AWS website and look for IoT, you can find them. You don't need one to get started. You just need a computer to be able to publish message to AWS IoT. In the web console, there is already an MQTT client that you can use. But if you want some hardware, you can find some over there. And again, you can buy any hardware that you want and connect it to the platform. It's not limited to those kits, but we wanted to help you get started quickly. The ecosystem is broad. We have a lot of partners and system integrators that can help you either to create the products or so create the hardware or create the projects or both. So here is why we have this broad ecosystem, is to help you achieve your projects. We are almost at the end. One message that is really important and that you must remember today, that if you're doing IoT, you really should concentrate on the value. Connecting objects is the first step, being able to receive data into your object. But really, the end goal for you is to think of a business model or a way to transform your business or to create a new one thanks to what you can do now with either those objects that are now connected or with the data that you get. That's why it's a big trend today, is that it enables new use case, new things to do in your business. Right, so we'll have a little time for even a demonstration. So let me show that to you here. So this demonstration, here I'm onto a web page that I will refresh. I cannot do, it's a webinar, so the format is a little bit different than what I'm used to, you know, when doing this on stage. So we can only do parts of the demo, unfortunately, but it will be interactive. So first I will run the demo with just my smartphone in real time, but then we can all try to do it. So here you can see on the screen, this one, I will refresh the web page. This is the client's interface. This is the one that you will use. And now it says I'm connected. And I have also an admin interface that is here. And you can see here that it was able to pinpoint the connection on the map. And also I can, for example, change the slider here. And if I go back to the other interface, I will see also the change happening. Let me refresh that. And you can do that with your smartphones as well. So if I go back to the presentation, you can take your smartphone from out of your pockets and just open a regular browser, so Chrome or whatever you have on your smartphone, and then enter this URL address. So it's https://bit.ly /IoT client. So again, https://bit.ly /IoT clients. And then you should get the web page that I'm seeing here. And I should be able to get you on the map and to see where you connected. So here I just did it with my smartphone. So I'm here in Paris. We can see that the number is growing. It's 11. We can see iOS as well. So I will zoom out because you are probably more in India right now. Let me zoom out a little bit. So this demo was really a prototype, not meant for production. Oh, and we can see you guys popping over here in India. So we have people in New Delhi, for example. Let me zoom in a little bit on that. All right, here you go. So we have a lot more not mobile people. So not mobile is everything different than Android and iOS. So the ones that are doing this are probably connecting from their desktop, so from their computer and their laptop. So actually here you are, most of you, 44, are connecting from that. I will zoom out a little bit to see where other places in India. I should line up. Well, here we have one here. Mumbai and Pune, without surprise, are also a big part of this. Okay, so now there are 92 of you. So this dashboard is refreshed every 5-10 seconds. Hyderabad is big too. Okay, so I will let that run. And so if you take a look at your smartphone or your computer, it should say that you are connected now. And when I'm changing the slide, you should see the bulb on your smartphone that refreshed and that has lit up, and the value should match. So here I'm getting 19% of brightness. I will put it back to 100. And also I will click on a show device, and you know, we can see the data on here as to where you Android or iOS. But by clicking this button now on your device, it should show with the new screen, either if you are on Android or on a laptop or on iOS. And here you can see I'm on my laptop. So it's not iOS or Android. So just a little bit of feedback while we are watching the number growth here. It's using WebSockets. So here the connected devices are actually each and every one of your smartphones. Okay, it's loading a web page, and then it's using the HTTP interface to AWS IoT. To be precise, it's using WebSockets over HTTP. So it can send data in real time, but you can also receive data. The light bulb that you are seeing here with the brightness, it's using device shadow. So whenever I change, you know, the brightness, then you got a notification, a real-time notification. And you got that thanks to device shadow, because in the web page we were listening for any notification that could happen. Okay, and when I clicked on show device, and you saw appear on your smartphone Android or iOS, or not mobile because you were on the web, I actually sent a message that you were listening on your smartphone, an MQTT message, to look out for the user agents that your browser is using. And then depending on the results, I was showing, you know, if it was either Android, iOS, or something else. You know, those things are not 100% accurate, so that's why I limited to only show Android or iOS or something else. If you have another device, BlackBerry or something else, it will go also into the not mobile category. Okay, so thank you everyone really for you know, playing the game. We can see that in Chennai we have people as well, Bengaluru, Hyderabad, Pune, and Mumbai. So that's really great. Thank you for playing the game. We have more than 300 of you right now. I will just go back to the presentation, and now it's finished. We have the Q&A part. So for the Q&A, I would need just a few seconds to see the question that you sent into the chat window. So let me read those questions, and then I will answer.